When simplifying more complicated expressions, always try to visualize repeated multiplication. I think it's useful to show repeated multiplication using algebra tiles. If you go to mathicon.org and click on Polypod and then algebra, that'll reveal the algebra tiles. Here's an x squared and here's a negative x squared. To expand the x squared, we need to realize that this 2 means that the base is being multiplied twice. That's repeated multiplication. The dimensions would be x times x, which makes the x squared. Negative x squared is a little bit different. We write the negative on the outside of the base. The repeated multiplication is only with the base of x. So x times x is what we have. The negative's out in front. You could also write it with a coefficient of -1 times x, and the dimensions would be negative x times the positive x. We should probably show what negative x squared looks like. We have the base being multiplied twice, which makes a positive x squared. We could write it like this. As we start reviewing the exponent laws, keep this repeated multiplication concept in your head. Find the value by expanding and then evaluating without a calculator. We want to focus on 2 things. First is repeated multiplication, right here. And second, the negative exponent law, right here. Have a look at the 5 examples and pinpoint the bases. 3xy, negative 3xy, 3xy, negative 3xy, and here, just the y. First example, the base is 3xy, and the base is being repeated twice. 3 times 3 is 9, x times x is x squared, and y times y is y squared. Second example, the base is now a negative 3xy. Negative 3xy is being repeated twice, and we get negative 3 times negative 3 is positive 9. X times x is x squared, and y times y is y squared. Same answer, because an even number of negatives will result in a positive answer. We saw that this answer was 9x squared y squared. What's the difference when there is a negative 2 as the exponent? We can't think about repeated multiplication when there's a negative exponent. What we need to do is apply our negative exponent law. The entire base will end up going to the denominator, and the exponent switches to a positive. The numerator becomes the 1. Then we can repeat the multiplication and get 1 over 9x squared y squared. A little bit different than this one. We saw that this answer was 9x squared y squared, and we need to compare that with what happens when we have a negative 2 exponent. We would apply our negative exponent law and send the base down and change the exponent to a positive. We'll get 1 over negative 3xy times negative 3xy, put brackets there, and that will leave us with 1 over 9x squared y squared. Again, a little bit different than when the exponent is already positive. Now, how is double D different from the single black diamond? The difference is we don't have brackets. We still have the negative 2, but the base is just the y. We keep the negative 3x in the numerator, and the y is the one that goes to the denominator with the switch, and the negative becomes a positive, and that's the final answer, right here. Keep in mind, we could put the negative right here for the entire fraction, just on the outside. So that could be there. Either answer is correct. Good job. Now that we have a really good understanding of repeated multiplication, let's simplify using the power of a power exponent law. In particular, we're going to look at the power of a product. Recall that the base here, 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 and here is a little more complicated than just this single y. In the first 4 questions, the base is made up of a product. When we have a product, we can apply what's called a power of a product rule. And what that is each factor that's part of the base has an invisible 1 exponent. What we can do is distribute the outside exponent to all of the inside ones quickly. What we would get is a 3 to the power 1 times 2. X to the power 1 times 2, and y to the power 1 times 2. And that leaves us the 9x squared y squared. Getting the answer this way is using an exponent law called the power of a product. But again, always fall back on the repeated multiplication concept. Hopefully you can double check your work and realize that it's 3xy times 3xy, which leads us to the 9x squared y squared. Let's try the second one. All of these have exponents of 1. The power of a product rule says we can distribute the outside power or exponent to all of the exponents that are part of the base. We would have negative 3 to the 1 times 2, which is 2, x to the 1 times 2, which is 2, and y to the 1 times 2, which is 2, which results in the 9x squared y squared, the same answer we got by thinking about repeated multiplication. Now here we have a negative 2 as the exponent. Again, inside all of these exponents are 1, and we can apply our power of a product rule right away. We would have 3 to the 1 times negative 2, which is 3 to the negative 2, x to the 1 times negative 2, and y to the 1 times negative 2, which results in applying the negative exponent law to each one of these. We'd get 1 over 3 squared, x squared, y squared, which is 1 over 9, x squared, y squared. The other path to take is to apply the negative exponent law right away and complete this question this way, which would be 1 over 9, x squared, y squared. We can do the power of a product in the denominator as well. Fourth one, we would realize that there's an exponent of 1 for each of these factors, and we could apply the power of a product rule. Negative 3 is the base to the power negative 2, because negative 2 times the 1 is negative 2. X to the negative 2, y to the negative 2. We're multiplying each of these exponents inside by the negative 2. And that results in applying our negative exponent law. Negative 3 is the base. It goes down and the exponent changes to a positive right here. This one, x is the base, goes down, change to a positive, and the y to the negative 2, the base goes down and the exponent changes to a positive, which is 1 over 9 x squared y squared. And just as a review, we could have done the negative exponent law first And that would result in 1 over 9x squared y squared. Same thing, because these ones have a little 1. And we would apply our power of a product rule. And the last one, we just have a negative 3x on the top for the numerator, and the y is the base that goes to the denominator with the exponent changing to a positive because we use the negative exponent law.